Ever wondered why an apple turns brown or why baking soda makes bread rise? These are all questions of chemistry. Chemistry is the science that deals with the properties, composition, and structure of substances, as well as the transformations they undergo during chemical reactions. It's not just an academic subject, it's a part of our daily lives. From the food we eat and the air we breathe, to the clothes we wear and the medicines we take, chemistry is everywhere. This video will be your guide to the basic concepts of chemistry following the Class 11 NCERT CBSE syllabus. We'll explore the nature of matter, delve into the mole concept and stoichiometry, and understand the laws of chemical combinations. We'll unravel the mysteries of atoms and molecules and see how they interact to create the world around us. So, are you ready to delve into the fascinating world of atoms and molecules? Let's begin. The universe is made up of matter, but what exactly is it, you might ask? Well, let's dive into it. Matter is anything that occupies space and possesses mass. It's what makes up everything you see, touch, taste, and smell. It's the air you breathe, the food you eat, the clothes you wear, and even you yourself. Matter comes in three basic states: solid, liquid, and gas. Solids have a definite shape and volume, liquids have a definite volume but not a definite shape, and gases neither have a definite shape nor a definite volume. Now let's talk about the particle nature of matter. All matter is composed of tiny particles. These particles could be atoms, the smallest unit of an element, or molecules, which are made up of two or more atoms held together by chemical bonds. Understanding atomic and molecular masses is crucial too. The atomic mass of an element is roughly equivalent to the number of protons and neutrons in the nucleus, while the molecular mass is the sum of the atomic masses of all the atoms in a molecule. By studying these properties, we can predict how matter will behave under different conditions, which is the heart of chemistry. It's a fascinating world, isn't it? So, matter is everything around us, and its study forms the basis of chemistry. Have you ever heard of the term mole in chemistry? No, it's not the small animal. Let's dive right in. In chemistry, a mole is a unit that measures the amount of substance. It's one of the 7 base units in the International System of Units, just like a kilogram or a meter, but it's used for particles like atoms, molecules, or electrons. So, how many particles are in a mole? Well, a mole contains approximately 6.02, 2 times 10 to the 23rd power particles. This number, often referred to as Avogadro's number, is a fundamental constant in chemistry. But why do we need the mole concept? It provides a bridge between the atom and the macroscopic world. Imagine trying to count the number of atoms in a sample of copper. It would be impractical, if not impossible. But with the mole concept, we can easily relate the mass of the copper sample to the number of atoms it contains. Now, let's shift gears to stoichiometry. In Greek, stoichiometry means measuring elements. It's a segment of chemistry that deals with the quantitative relationship between reactants and products in a chemical reaction. For example, consider the reaction of hydrogen with oxygen to produce water. The stoichiometric equation is H2 plus O2, H2O. This equation tells us that 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. And that's stoichiometry. It allows us to predict how much of a reactant is needed or how much of a product will be formed in a chemical reaction. In the real world, stoichiometry is applied in many areas, from designing chemical reactions in industry, to understanding biochemical interactions in our body, to predicting the behavior of gases in the atmosphere. Stoichiometry, as you can see, is a powerful tool that allows us to predict the outcomes of chemical reactions. Did you know that there are laws governing how elements combine to form compounds? Let's dive right into the first one, the law of conservation of mass. This law states that mass can neither be created nor destroyed in a chemical reaction. Essentially, the total mass of reactants or the substances that start off the reaction will always equal the total mass of the products or the substances that are formed by the reaction. This law is like the strict parent of chemical reactions, ensuring that everything remains balanced and orderly. Next, we have the law of definite proportions. This law dictates that a chemical compound will always contain the same elements in exactly the same proportions by weight, no matter how much of the compound you have. This law is like the meticulous mathematician of the chemical world, ensuring that everything stays proportionate and consistent. But why are these laws so crucial? Well, they form the basis for how we understand and predict the outcomes of chemical reactions. They allow us to calculate how much of a reactant we need to produce a certain amount of product, or to figure out how much product we can expect from a given amount of reactant. These laws form the foundational principles of chemistry, guiding how elements interact to form new substances. Well, that was a quick journey through some basic concepts of chemistry, wasn't it? We started off by delving into the nature of matter, understanding its characteristics and how it forms the building blocks of everything around us. Then, we moved on to the mole concept, a fundamental tool in chemistry that allows us to count atoms and molecules by weighing them. It's like having a microscopic measuring tape at our disposal. Next, we ventured into the realm of stoichiometry, the aspect of chemistry that deals with the quantitative relationship between reactants and products in a chemical reaction. It's all about balancing, really. Finally, we examined the laws of chemical combinations, the principles that govern how substances combine to form new ones. These laws are the rules of the game in the world of chemistry. Remember, understanding these basic concepts is essential for your journey into the vast and interesting field of chemistry. Keep exploring, keep learning, keep